Okay. All right, the complex plane, blah, 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 blah. We talked about this before. You've got a and what you don't see a lot of this in two dimensions, because what they're doing is they're warming you up for what? I'm holding up a 3 dimension. They're getting you ready for 3 dimensions, okay? The unit vector pretty much is going to do a lot of this, but when you're talking about 3 dimensions, you're talking about adding that 3rd dimension right there. And you've got a 3-dimensional graph with, I usually do Y, X, and Z. Now, some of your teachers, does it matter if they make Z go up? No, it doesn't. That's something else you need to get used to. Some teachers, your physics teachers, will have Z coming out the board, while your math teachers will have Z going up. Don't ask me, okay? It doesn't matter as long as you can see which is which. The reason I do this is because all of us are used to, since pre-algebra, seeing the XY plane like what? Like this right here. So that's why I put the XY plane like this, because we're used to seeing it from this direction, and we see it that way, and Z comes out. All right? Now that's just something I do, but in the 2-dimensional sense, basically you're talking about changing 2, 3 into another type of coordinate, and that's called a polar coordinate. Okay, now what they're getting you used to here, I'm going to switch to the whiteboard, and I think I've told you this before. Okay, I've got to go to, let me get out of this. I'm sorry, I was having a brain bubble there. Let me go to the whiteboard. What they're getting you used to is this. Whiteboard, whiteboard, whiteboard. They're getting you used to, and I'm going to try to draw this without messing it up. I need a poster. Got this, this, and this. And we're talking Calc 3 here. And I want to know the speed of that particle in space at blah, blah, blah. Okay? Blah, 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 blah. And that is totally messed up. Let me just redraw it because I don't like that. Just give me a second. I'm not an artist, so. And that's something else you need to get used to doing, drawing in 3 dimensions. There we go. And I want this particle in space. That particle, you have to actually, now I'm not getting the cart before the horse. What I'm doing is I'm trying to show you, for those that are listening, is everybody listening? Because I see people playing on their phones, on their calculators, and playing with their hands, okay? It's called courtesy. Everybody with me?
Yep.
Okay. Yep. So I'm going to take, and I'm going to draw, got this right here. I'm going to do this in red. Got this right here. And then you got this plane here. Red goes this way. In other words, you've got to start looking in 3 dimensions. Of course, I can't do the other one, but that position vector, and I'm going to do it in green, that position vector is going to come from here, and it's going to go right there. And that's your position vector. And you can see, I'm trying to show you the 3 dimensions by using and I'm not a good drawer, so there's the 3 dimensions. You got 1, 2, and then 3 going up. So you got 3 dimensions, and that from that point right there, you're going to be looking at a coordinate of x, y, and what? Z. And the polar is going to be in form of I, J, and what? K. All right? So everything that you learned back in the Cartesian coordinate system, right here, back in 7th, 8th grade, we're starting to evolve. We're starting to go, okay, well, we started here, and we got a point here, and we called that 3, and this 2, and we used Pythagorean theorem, blah, blah, blah. Okay? Now you're going from a Cartesian coordinate system into a 3-dimensional polar coordinate, which means that you're not doing this particle here like the algebraic ways. Now you're going to a calculus base, which means a point or a particle in what? In time, in space or time. You're getting there. With the differential equations, you're going to be getting into time. All right? Now you got to start thinking out of the box here, because most of y'all are not in 3rd or 4th degree, graduate classes. Most of y'all have been thinking in terms of this, and some of you may have started in terms of the 3rd dimension, meaning your physics or your calculus. All right? But now why do you need the IJ and K? The IJ and K represents the polar coordinate. Okay? Think of it like this. The Earth is what? The Earth is, well, actually, it's more like elliptical. Okay? But if I wanted to, let's say I was looking at a view from bird's eye view of a point. Let's say this is North America. Okay, laying like that. All right? And I'm looking at a point right up here. Then that from this point up here, you basically have a 3-dimensional. You can't draw, it's hard to draw a sphere on a 2-dimensional board, but you've got 3 coordinates to that point in space. And that's what everything is based on polar coordinates. Okay? So that's where we're heading with this. And when you're talking about, and for those of y'all that's paying attention, I appreciate it. Let's go back to the polar coordinate part. I should have put all this on a dadgum poster. I'm sorry. But I'm just way behind on technology. So y'all just going to have to bear with me. Hold on a second. There we go. And I'll probably erase all that now that you can look at it. So the things that you did way back in pre-algebra, okay, erase the whole thing. From 2, 3 is now going to be called, and 2 and -3 is now going to be called 2 and 3i. Whatever. I don't know why I want to erase. For some reason, it's going bonkers. The horizontal axis, the x-axis, is your real axis, and the imaginary is called the y-axis. Basically, this says 2 minus 3i, 2x minus 3y. That's what it says. All right? So you're going from a 2, -3, which is this is x and this is y. Whenever you see this basically means 2, -3. Okay? Right here. This means x is equal to 5 and y is equal to what? 4. Okay? But remember, what they're trying to get you to do is think in terms of 3 dimensions for later. And that's going to be 5i plus 4j plus or comma 5k or whatever. But we're talking later on down the road. Find the sum of 6 minus 2i and negative 4 minus 3i. Graph. So graph those. And their resultant. So 6 minus 2i, so that's going to be like 6 and negative 2. And then negative 4 and negative 3. So if I wanted to graph this as a 2-dimensional graph back in the Cartesian coordinate system. 1, 2, 3, 4, 5, 6, negative 2. There's that point. And I'll do that in, let's do that in red. We'll do this one in red. Okay, and negative 4 minus 3i, we'll do that in blue. Negative 4 and negative 3. All right, now I'm going to try this, and it'll probably blow up, but I'm going to try it. I know it won't work. Of course not. I wanted to try to move it, but it's not going to let me move it. So, things I try to do for y'all. One day we're going to get training. All right, there's my rendition right here. And you can see my blue line and my red line look like this blue line and this red line. Now, what I was going to do is I was going to take my blue line and pick it up and move it down here like this. Everybody see? And then that would give way to the what? Resultant vector, which I used head to tail, and I'm going to color that magenta. And the resultant vector, I'm about ready to quit, is right there. Okay? Now how do you find it? Well, what's 6 minus 4? Okay, 2. So I'm going to take my handy dandy 6 minus 2i. And it said, find the what? The sum plus negative 4 minus 3i. And that's going to be 6 plus a negative 4, comma, negative 2i plus negative 3i. And 6 minus 4 is 2. And negative 2i plus a negative 3i is negative what? Now, of course, it's a vector, so you would probably, since they want the resultant vector, you might want to write it like that, but it all depends on the context of the question. To me, that is secondary to you actually knowing what to do. Okay? The mathematics is most important. Okay, who's got a question on that one? Okay, it seems pretty easy. But when they start nesting these problems and they start combining things on top of one another, it starts to get a little bit fuzzy. Any questions on that one? All right, the graph shows the complex. Oh, look over there. R sine theta, R cosine theta. Okay, this is another highlight time. Now, you have seen this through several different chapters, several different units. Now is when you need to take the highlighter out in green, and you need to highlight this box. You need to write it down, and you need to put it on an index card, and you need to memorize it. Because what they're saying is, in physics, this is what you're going to use. R cosine theta, R sine theta. I think I told y'all this before, didn't I?
Yeah.
Okay. And of course your Pythagorean theorem, which is your magnitude of your resultant vector, and to find your angle, y over x. Now, all of you should have all that. It's already in your notes, but I'll give you a couple more seconds to write it down. I would highlight that in red. I would put take a red pen, a red crayon, a red highlighter, and highlight it. I would put a tab on the outside of your page. You're going to see that over and over and over again in physics and in calculus. Write this down also. This is very important because this is going to be your homework in 10.5. Now, if you just look, if you want to write x and yi, then you're going to put r cosine theta and r sine theta into this right there. And that's going to give you r cosine theta plus r sine theta I. Now this right here is what you're going to see in 10.5. So if I want to change a trigonometric form into a polar form, I would use this, okay? And if I wanted to go from polar form to trigonometric form, I would reverse it. And you're going to see that with the next, probably, example. Okay, they're going to give you this, cosine, sometimes written. Okay, cis. Go ahead and write down that cis theta because sometimes they do call it cis. You're going to see also... I can't think of it right now, but I'll think of it in a minute. But there's other forms of cosine and sine and tangent. Cosh, there it is. Sinh, cosh, and tanh. Okay, the hyperbolic sine, the hyperbolic cosine, and the hyperbolic tangent. It's called sinh and cosh mostly. Now here is where they take and they take cosine plus I sine and they write it as cis. To just, instead of writing all that out, they just change it to cis. So if you ever see cis theta, that means basically that right there, okay? The number is called the modulus or absolute value, and angle is called the argument. I rarely ever see that, okay? You might see it in your homework, but I doubt very seriously I'm going to call any of those on a test. Here is an example. Now rewrite. I want you to write at the top. What does it say? It says converting from trigonometric form to rectangular form. That's what you're doing. You need to highlight that because we're going to probably have a couple of examples where we're going from trig to rectangular and rectangular to trig. You remember the shortcuts in algebra? You have to be fluent in this, just like you were the shortcuts. Now there's some things I'll tell you can get by with. You know, I gave y'all the identities, but what I tell you to use? I told you to use the cheat sheet, which maybe 5 or 6 of y'all actually printed out. Okay? This, no cheat sheet. You need to learn how to do this. Just like you have to learn how to change from polar to rectangular and rectangular. I mean, not polar. Radians. From radians to degrees and degrees to radians. You have to know how to do that. You have to know how to do this without even blinking an eye. Okay? So express 2 cosine theta, or 2 cosine 300 plus I sine of 300. It's not very difficult. Once you see it, you're going to say, oh, that's not hard at all. What do we got to bring back? Our special what? Special angles. What is 300 degrees?
Well, it's 270 plus what? 30. But 30 would be 60, would it not?
Okay, so you're talking about your 30-degree angle in the what quadrant? 4th quadrant, which is really 60 degrees. So you got to go back to your 60-degree angle. And there they are. And look, you just write the 2, and then that. There it is. Now remember, and where does that come from? And I'm just writing this down for people that may forget. I'm writing a purple and it's not. There we go. Okay. Here's 270 right here. 300 is what? Right there. And if you think about it, these are outside the cosine, they're outside down here, remember? The cosine is first, 1/2, comma what? Square root of 3 over 2. And you just simplify. Most of the time, it will be special angles. I'm not going to get up there and say on a test question, okay, let's say express 2 cosine of 32.5 plus I sine of 32.5. I'm not going to do that. You can do that in the calculator anyway. Brenda? How many of you have seen this before? Pendleton, get a synopsis around the room. How many of you have seen this before and have you remembered it? Just give me an idea. Have you seen it before? We'll start on the right side of the room over there.
This side? Which
No,
way?
you're right.
No. No. Yeah.
No. No.
No.
No.
Okay. No meaning you don't remember it or you haven't seen it.
I haven't seen it.
You haven't seen it? Okay. How about Easley Campus? Starting on my left side, your right side of the room. Have you seen it before?
I haven't.
You haven't?
Nope.
I haven't.
Nope.
I haven't.
No.
No.
And Miss Crittenden?
No, I haven't seen it.
See, she's up there drinking again. She's putting it in some kind of cup, but she's drinking. Y'all pray for her. All right. So, who has a question? Does everybody understand how we went from the the trigonometric form to the rectangular form?
Yes.
Okay? Remember your special angles, and remember, hold on, that right there. Now they're going to give us another one, probably. That's what I would do. And that is go the other direction. Now you can do it in your calculator, but you're going to get that number. Okay? That's not going to help you unless they're asking for what? Decimals. There we go. Converting from rectangular form, this is the easy one. This is the one I always like to do. I always wanted these on the test. All right? Draw a graph, find your R, find your theta, plug and chug. So here we go. I'll leave that for you so you can write it down. Sketch a graph. Hubert's told us to do that a lot. Sketch a graph. Get used to those free body diagrams. Find R by using the equation R squared is equal to the square root of x squared plus y squared. And find theta by using the equation tangent of theta, and that's what we had in that box a while back. Okay? When you sketch it in the form of x plus y, that helps you out more than you think. And there's your equation. The first one is negative square root of 3 plus I. Now, what does that really mean? What is the negative? What is the square root of 3? Hey, I heard a mumble. That's progress.
Is it R?
What's the square root of 3? 1.7, isn't it? Yes, Hubert. So that's 1.7 plus what? Plus I. Okay? Well, think about it. What is that? 1.7 and I. That's like negative 1.7 plus what? 1? Yes? And negative 3i. And you put those on the graph. Oh, shoot. Sorry. There. Okay, because where did that 1 come from? Well, what is this? What did I tell you it was? 1i. So that's where the 1 comes from. I always got these right on the test. Okay? Because this was easy for me when I was in trig and physics. Now you got the Pythagorean what? Pythagorean theorem. If I want the angle, I just do the tangent. Oscar had a hump of apples, so that's going to be 1 over what? Negative square root of 3, which is going to be what? Negative square root of 3 over 3? 3, negative 3, yeah. Whatever. Square root of 3 over 3 or something like that. And take the inverse tangent of negative square root of 3 over 3. I'm trying to get to that part. Okay, they did it in terms of... So take the inverse tangent. Somebody take the inverse tangent of the negative square root of 3 over 3 and tell me what you get. Put it in degree mode. Or you can do 5 pi over 6 and then change it into what? 180 over pi, which 6 will go in 150 degrees. Yes, no, maybe. I'm waiting. How much? 150? So it's in quadrant what? 2. And that's what it says right here. So you can do it degrees. Remember what I told you. Find out where you are. If you know it's 150 degrees and they want it in terms of pi, then change it into pi. If they have it in pi and they want it in terms of degrees, then change it into degrees. But make sure you know what it looks like. Capiche? And you can tell that from that drawing. The angle is in quadrant 2. I always have students that say, well, I really don't need to draw a picture. If you're one of those people that say you don't need to draw a picture, you will fail physics. I'll go ahead and tell you that right now. Even though you think you invented it, you will fail physics. You're going to have to draw a free body diagram. Now, after you find R, what do? I mean, after you find theta, what do? Plug and what? Plug and chug. Now, you could write it as 2 cosine of 150 plus I sine of 150, or 2 cis 150 degrees. You can write it either or, but what do you need to read to make sure that you turn in the right answer? The directions. Context of the question. If not sure, write both of them and put or. Question. Now, are we talking a very difficult mathematics here, or are we talking pretty simple? This is pretty simple, but you have to organize and you have to get your own method / procedure to doing this. You're not going to get it by looking at it, Chevy Chase at the Grand Canyon, and by osmosis learning how to do it. You're not going to be able to do it that way. All right, now the second part of the question, I didn't read the second part. Oh, 3i, I think it was 3i. There it is. So that means 0 minus 3i. So you've got, basically, it's a quartic. I mean, it's on the axis. So it's an axiom. It's on one of the quartics. So that's going to be 270 degrees. And that's what you do. Now, if you wanted to put 3 pi over 2, you could. But there's nothing that says, now that's why they write 3 cis 270 or 3 cis 3 pi over 2. So I think the biggest thing you have to get used to in this section is when you see it written like this, you know it's 0, negative 3. And when you see it written like this, it's what? Negative square root of 3, what? 1. You need to make that relationship. We feel good so far? Ignore. I don't know why this is when they just do something really stupid, okay? You don't need to worry about a Julia set right now. Maybe third or fourth level mathematics, we don't need to worry about that. Ignore that. Okay, make sure you make a note here. Multiplying complex numbers. Look at there. Make sure you can do the FOIL method. And make sure you remember the FOIL method here. So you need to write down this one right here and make sure you can FOIL it. I don't pronounce the word FOIL, DOG, or LOG because there's always one perfect person in the audience that says that I'm saying it wrong. So that's why I do not say CLEMSON either. So what do you do? Well, what's 1 times negative 2 square root of 3? Negative 2 square root of 3. 1 times 2i is 2i. Negative 2i times 3 is negative 6i. And then, wait a minute, how'd you get that, Hubert? Well, negative 2i, and then square root of 3 times square root of 3 is what? Square root of 9, which is what? 3. 3 times 2 is 6. All right, now watch this right here. What happens here? I square root of 3 times 2i. What happens there? Somebody tell me what happens. I don't want it mumbled. I want you to tell me what happens. Okay. Appreciate the interaction. I don't know is not an answer because we've already covered it. Somebody multiply those two right there and tell me what you get.
Negative 2 square 3 times square.
Okay, how did you get a negative 2 out of that? Because it's positive I times positive 2i.
I was looking at that.
No, you're right. But how'd you get the negative 2?
Because
I squared is negative 1.
Who said that? Who said that?
This guy.
Thank you. You're the one that paid attention. And you. Thank you. You were saying it too, right? I squared is equal to what?
Negative
Write
1.
that down. I squared is equal to negative 1. We talked about that in the algebra review. And that is what's going to get you on the test. When we go into 10.5 questions, that's going to get you. Because what y'all will do, this is what y'all will do. Let's see, I times the square root of 3 times, go away, times 2i. Okay, that's going to give us 2i squared, square root of 3. And that's what y'all will come up with. And it is 100% wrong. Now, look at it in trigonometric form. Here's the trigonometric form. Now, how are you going to do that? Well, you can do it two different ways. Okay, you can leave the 2 and the 4 out and just leave it out here like they did right here. And then you could do the FOIL method right here. Or distributive law, whichever one you want to call it. However you want to call it. But the main thing is your algebra is not going to go away. So first, outer, inner. What does that last do? What's I times I? I squared, which is equal to negative 1. Okay, out of all this right here, where are students going to screw it up? They're going to screw it up right there. and you're going to get the whole problem wrong, just one little piece. So you got to remember that stuff. Capiche? Because all the rest of that's nothing but 100%. This is a good calculus problem. Remember me telling you in the identities that you're only introduced one new piece, and you got to fall back on 9 pieces of algebra, 1 piece of trig. Okay? That's right here. So if you suck at algebra, you're going to suck at that question. Same thing with calculus. And of course, 2 times 4 is 8. And then you just combine everything that you can combine, and it comes out to this right here. That's a good test question. This right here, that's a good test question. So you might want to put that in your notes. I'll give you a second for those of you just sitting there and staring at it and didn't write it in your notes to go ahead and write it in your notes, because that is a good test question, and I don't want you to screw it up. Not that any of you would, right? Because y'all can't break an anvil with a banana. Now, I don't know if this is true or not, but I read about this because I said anvil. Somebody told me that they were actually coming out with 2 movies. One is the Coyote versus the Roadrunner. I don't know if that's true or not. Somebody needs to Google it. And then the other one, somebody told me that Michael Jordan was going to do a Space Jams 2, or what's it called? The Space Jams?
Yeah, Space Jams, yeah.
Is that true?
That one is.
Remembers about it.
That's going to be cool.
I thought it was LeBron James.
Well, it'll flop if it's LeBron James. If they do it right, it should be Michael Jordan, but if it's LeBron James, it won't. What about somebody Google and see if they're going to do a Coyote and Roadrunner. They were going to do it kind of like the Space Jams, where it was kind of like animated, but not animated. You know what I'm saying? Forget it. For those of you that don't know what an anvil is, you watch, oh, forget it. You probably don't even know what Roadrunner is. Forget it. Product theorem. Go ahead and write it down, but it's not a big deal. It's basically telling you how to shortcut to the FOIL method. Go ahead and write it down. Then you have 2, and you're multiplying. Instead of using the FOIL method, basically, take the 2 coefficients, multiply them 2 together. I think y'all see that's pretty simple. And then you use the FOIL method, and you do cosine of theta plus I sine of theta plus theta. And that's just a shortcut on doing the FOIL method.
Supposedly it's in works from the director of Lego Batman.
So it is. So Coyote and Roadrunner is not a rumor.
Yes, supposedly it's in development
Huh?
at Warner Bros.
That's neat. What about the other one, Space Jams 2? Oh, thank you for the interaction. I appreciate it.
LeBron James Space
Yeah.
Jam 2 set to film in California.
Next, find the product of. Oh,
Go back.
y'all know y'all don't have to write the whole thing, don't you? You just have to write this down right here. These 2 lines right here. R. That's all right. I'll just wait. Tell me when you're ready. pretty simple to remember because what comes first in the alphabet, X or Y? X, and cosine's first. Remember your unit circle? Cosine's first, or cosine of theta is equal to X. So cosine's first, and then you just take the two angles and add them together. And then I is your Y vector, your Y coordinate. So that's going to be I sine. Sine goes with the Y, and then add the two. So it's not very difficult, especially when you put it like that. So that's going to be 6 cosine of, what's that, 180? Plus I sine of 180. Go ahead and plug and chug if you need to. And then once you get it in the cosine of 180, 180 is a special angle. What's your X of your 180?
-1.
-1. What's your Y?
0.
0. So you plug and chug. And I'll give y'all a hint. 0 cancels out everything. So your I is gone. And think about it. What is your vector of 180 degrees? Straight down. Okay? I'm sorry. Straight to the left. I'm sorry. I was thinking of 270 we did like that. So that's why you do not have a what? You don't have an I form, which you don't have a Y, because it goes straight to the left. And again, I'm not trying to insult your intelligence. I'm trying to show you what the product means, what you're actually finding. So you could have went 3 times 2 is 6, and then 135 plus 45, that's going to be cosine of 180, plus I sine of 180, and boom, you're done. And once you get to this point, then you go back to your special angles. All right, who does not understand that? Who needs help on that? And that's a good test question. All these, this is one time that the slides actually picked some good problems. They actually did, whoever did them. Last class, in 109, I had a slide that came up that had 2 typos in it. So far, no typos. Everybody good on this one?
Sir.
The rectangular form of a quotient of 2 complex numbers. What are we going to use on this one before we even get started on it? Starts with a C. What's in the bottom? What's in the denominator? Radicals, Hubert. Yes. And what do we use when we want to get rid of the radicals? Starts with a C.
Conjugate.
Conjugate. So you're going to use the conjugate, which means you're going to use the FOIL method in shortcut number 3. I don't know why they gave you the whole thing. I would like for y'all to do it instead of, hold on a second. This is one time that I wish they'd actually just take that, save. Let's go to the whiteboard. Escape, keep. Whiteboard. I'm making my own poster. Sounds good.
Wow. That's really innovative.
Yeah, thank you. It don't keep up with those that I saw at the faculty staff workday, but it's close. All right, so let's use our conjugate. What's the conjugate of -2 square root of 3 plus 2i? Say it one more time, a little bit louder so everybody can hear you because they can't interact.
Square root of 3 minus.
Minus 2i. So I'm going to -2 square root of 3 minus 2i over -2 square root of 3 minus 2i. And of course, most of y'all do what after this? Quit. Because that's just too much work. I mean, the bottom is shortcut number 3. I mean, which is going to be 4 times 3 is 12. It's going to be squared, so it's going to be 12 plus 2 is 14. Somebody do the bottom and see if you get 14. I did it in my head, so check me. I got drugs and alcohol in my system, so that's a joke. I'm not drinking a chocolate martini again. I was telling somebody the other day, how do you drink gin and not think you're drinking toilet water? Drink gin. You ever smelled gin? It just smells like pine sol.
Like bug spray.
Yeah. I can't drink it. So I have to, if I do drink a martini, it has to be a vodka martini. So my chocolate martini was vodka this morning.
Yeah, no.
I just do that to see if it gets back to my boss that I'm drinking. Did y'all get 14?
I got 16.
Okay, let me go back through and check it. Negative 2, square root of 3, quantity squared, minus negative 2, or 2i, quantity squared. Everybody with me? So that's going to be 4 times 3 minus 2 times negative 1, right? 4. I might have got that wrong. Yep, it's 16. Thank you. That should be right. Let's finish it. That'd be 12 minus a negative 4, which would be 12 plus 4, which would be 16. So I got it wrong. Thank you. 16. Okay, now how we do the top? Dang old FOIL method. Pronounce it however you would like. So 1 times the square root, that's going to be negative 2, square root of 3, minus 2i, minus 2i, square root of 3. Okay, I times I, that's going to be negative 1. It'll be positive 2 square root of 3. Check me. Oh my gosh, what happens to the 2 square roots of 3's? If I did it right, they cancel, right? And that's going to leave you with negative 2i minus 2i square root of 3 over 16. Cancel, cancel, cancel. So that's going to be negative I minus I square root of 3 over 8. What did they get? Y'all remember?
That looks right.
I think so. Y'all write it down and let's check and see if that's what we got. They got negative I minus I square root of 3 over 8. Now, how well should you have done that problem? You should have done it boom, 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 boom. If you're going, you're in trouble for 12.5 and you didn't learn what you were supposed to learn with the I's in the conjugate. So you need to do this problem about 5 or 6 times before you start on the 5, what did I say, 5.5 or 5.4? 5.4 homework, okay? Because that's where we're heading. And you're going to get several of these problems. Okay, let's see what they got. Where's that problem? It must be right here. Is it that problem or this problem? Is that it? What did they get? Negative. Okay, they got something totally different. I must have done something wrong. They got 16. Okay, but they got, okay, that middle term, somehow I messed up the middle term. Okay, first 1 times 2 square root of 3 minus 2i. I see what I did. Hold on, let me go back. I see what I did. I didn't write down the square root of 3 right here. That should be square root of 3. Outside first, outside, inside. No, that's not right. Yes.
The square of 3 times square of 3 is B3. Right?
Yeah, but there is no, okay, right here. First, y'all check me. First is negative 2 square root of 3. First, outside, negative 2i. Inside, there it is. There it is, the square root of 3. That's what I had wrong. The square root of 3 times square root of 3 is 3. Okay, that's right. And then negative 2i, so that's going to be negative 6i. That's where it comes in. Okay, they're right. I'm wrong. I forgot to do the square root of 3 times square root of 3. So, my bad. So much for my walking on water. Oh well. Maybe time. There we go. So your answer is 1/2 I, negative 1/2 I. Okay, what do you do down here? Well, you got 1 plus I times square root of 3 is equal to what? 2 cosine 60 plus I sine of 60. Now, what do? Well, it looks like to me they multiplied by 2 on both sides. Looks like. Well, why'd they do that? I don't understand what this one is. I don't understand what they're doing. Polar form, sorry. Okay, it looks like to me they're starting right here, starting the problem, and then, oh, this is 3 separate problems. I'm sorry. I thought they were actually trying to, I'm sorry, I thought they were trying to simplify this. It's 2 separate, these are 3 separate problems. Okay, let's move on. Okay, quotient theorem. Remember, if you have 2 things that you are dividing and the bases are the same, okay, then you can rewrite them, in this case, as addition, or subtraction, I'm sorry, right there, subtraction. Remember your exponents? If you subtract the exponents, that means you're dividing. Well, in this case, you're dividing, and you have to subtract the angles, right here. Now, let me go back. I'm sorry. It would help if I hit the button. There we go. Here, you subtract the angles. So, q sub 1 minus q sub 2. So, do you use this a lot? You use it a little bit, not as much as you do the product rule, but you can subtract the angles. And what do you do with the coefficients? You just keep them in the division just like you do right here. Okay, so the coefficients do not change. The only thing that changes is your angle. So it's going to be the first one minus the what? Sorry. Minus the second. Which you only have to do one time, so it's not really that difficult. Probably follow up with a example. What's negative 60 minus 150? negative what? 210? So your answer is going to be 10 fifths, which is 2, times what? There it is, 210 right there. 2 cis, 210. Now what is 210? 210 is 180 plus what? 30. That means it's in the third quadrant, and that means it's 30 degrees. So let's draw that 30 degrees because we know that we need to find where we are so we don't screw it up. So here we go. Dang old 30 degrees is right there, so that means the y is going to be what? Negative. And this is going to be negative. And what is our, that's negative what? Square root of what? 3. This is negative 1, and this is what? 2, Hubert. That's right, class. So, if I want to find the cosine of 210, the cosine, Oscar had a hump, square root of 3 over 2. That's this. And if I want to find the sine, Oscar had, that's going to be negative 1 over negative 3, which is square root of 3 over 3. I'm sorry. 1/2. Be Oscar had be negative 1/2, and negative 1/2 is going to go right there.
Excuse me, sir.
Yes.
That be second one?
210. Second what?
Second one. It's 150.
210. Oh, you're right. This way. I'm sorry, I didn't see the negative. Oh, suck today. I won't go eat turkey.
Me too. Turkey is good.
I think they should quit having school right before Thanksgiving. Just have it the Monday, don't just take out the Monday and the Tuesday. All right. 210. Thank you, Mr. Lee. There we go. Negative 210, which would be what? Negative square root of 2, what? 1, or square root of 3, 1 and 2. How about that? That might make it a little bit better. All right. Oscar had a hump. A hump would be square root of 3 over 2, negative square root of 3 over 2, and Oscar had would be 1/2. So that's where they get that right there, and then you simplify it. Okay? The zipper fetishes are telling me to look at my watch, whoever's having the zipper fetish. 12:05. What time's class over? 12:25? Or 12:35? I think it's 12:35, isn't it? Somebody tell me.
It's 12:35.
I thought so. So whoever's doing the zipper thing, quit being rude. All right, next. That's a joke. I was just kidding. Okay, that's it. So now y'all can go home. And this is what section? What section was this? 10.4. Now, you will be going into 10.5 when we get back. 10.5 and 10.6 are going to be a little bit challenging. So make sure you cover 10.1 through 10.4 homework while you're gone, okay? Have a good break. You too, Hubert. Thank you, class. Appreciate it.
Enjoy your turkey.